All right, this is the last video on stoichiometry, and the last topic that we need to talk about is percent yield. So pretend you are baking cookies, and on the bag it tells you that you can get a dozen cookies. So if we're baking cookies, the bag says you should be able to make 12 cookies for your recipe, which is kind of a small recipe, but it's okay. And when you bake them, when you scoop them out, you don't scoop them out at the exact right mass that the bag thinks you're going to. So you actually only make 10 cookies. Well, if you think about what you should have gotten, what the bag tells you should have gotten, so this is a predicted. Predicted, we'll call it a theoretical. A theoretical value. So if you take your predicted or theoretical and you have your actual, if you take 10 and you divide that by 12 and then you multiply that number times 100, you get 83.3%. This is the percent yield of cookies that you got. The percent yield is defined as the actual produced, the actual production, divided by the theoretical, and in brackets I'm going to put, another way to say this is the calculated. So when we do a stoichiometric calculation, we're calculating under the optimal conditions. If nothing goes wrong, if nothing spills, if nothing burns, if everything is measured out exactly right, this is theoretically what we should get. And we do that when we calculate. If we take that number times 100, that gives us the percent yield. Percent yield. So in a sense, that's all percent yield is. Well, how can we use that in stoichiometry? All right, let's look at our first problem. Quicklime can be prepared by roasting calcium carbonate according to the following reaction. I've got CaCO3 is Ca plus CO2. Now you'll notice that this is balanced. I have one calcium. I have 3 oxygen. I've got 1, 2, 3 oxygen, and I've got 1 carbon. So this one's nice and easy. When 2,000 grams of this, I'm starting with 2,000 grams of this, are heated, what I actually get of the CaO, so my actual, is 1,050. What is the percent yield? Well, it's telling me what I get actually. Whoops, up here on my formula I'm pointing to. What I don't know is what I should be getting theoretically. So I need to go to, if I start with this, if this is my mass of A, I need to find the mass of B. So I need to do a mass to mass stoichiometric calculation. Well, I'm going to start with 2,000 grams CaCO3, and that's going to go over 1. And I want to solve for grams of CaO. Now you'll notice I don't have my diagram written down. Hopefully by this time you're feeling a little more confident about your conversion skills. And so I'm not going to write the diagram this time, but if I go from mass to mass, I'm going to need the molar mass of this, I'm going to need the mole ratio, and I'm going to need the molar mass of this. So let's write my conversion factors. 1 mole of CaCO3, calcium's 40, plus 12, plus 16, plus 16, plus 16 is going to give me 100 grams CaCO3. Mole ratios are easy. These are all 1 to 1 mole ratios. So I'm not going to bother to pre-write those. I'm going to want the molar mass of this. Calcium is 40 and oxygen is 16. So this is going to be 1 mole CaO to 56 grams CaO. Okay, let's insert those conversion factors. This is going to be able to go in as is. 1 mole CaCO3 over 100 grams CaCO3. I have a 1-to-1 mole ratio, and I'm going to still write that in because it keeps my units where they're supposed to be. 1 mole CaCO3 to 1 mole CaO. And then I'm going to put this in, but I'm going to flip it because I need grams on top. So I'm going to put in 56 grams of CaO over 1 mole CaO. Let's cancel my units, make sure I set this up correctly. Gram CaO cancels, mole CaCO3 cancels, moles of CaO cancels. So when I take 2,000 times 56 divided by 100, I get 1,120 grams. And this is my theoretical. Theoretically, that's what I should get. So we set up above, percent yield is actual over theoretical multiplied by 100. So I'm going to take the actual yield is 1,050. I'm going to divide that by 1,120, multiply that by 100 to get it into percent form. And I get 93.8% yield. All right, let's look at another problem that's a little more complicated. Huge quantities of sulfur dioxide are produced from zinc sulfide by means of the following reaction. If the typical yield is 86.7%, how much SO2 should be expected if 4,897 grams of zinc sulfide are used? All right, so for this one, go ahead and balance the equation. Pause the video, and I'll see you back here. All right, did you put a 2, a 3, a 2, and a 2? I've got 2 zinc, 2 zinc, 2 sulfur, 2 sulfur. I've got 1, 2, 3, 4 oxygen. I'm sorry, 4, 5, 6 oxygen, and I've got 6 oxygen. Now this time, they're giving us the percent yield. So they're saying that the actual over the theoretical times 100 is going to be equal to, actually, let's just leave that off. Let's convert that to a decimal. It's going to be equal to 0.867. And they say how much should be expected. So what they're asking for here is the actual. And I'm going to have to find the theoretical. So I'm starting with 4,897 grams of zinc sulfide. So that's my starting. Going to put that over 1. And I want to solve for, we're talking about sulfur dioxide. So I want to solve for grams of SO2. Okay, again, I have a mass to mass. So I'm going to need some molar mass conversions. Zinc is 65.5 and sulfur is 32. So I know that I have 1 mole of ZNS. It's 65.4 plus 32 is going to be 97.5 grams of ZNS. Mole ratio here is not going to be a 1-to-1. I have 2 moles of zinc sulfide to, oops, well, yeah, it kind of is. 2 moles of SO2. If I'd had oxygen in there, it wouldn't have been. And then sulfur dioxide, I have 1 mole of SO2. Sulfur's 32, oxygen is 16, so 32 plus 16 plus 16. You know what? Is 64. Okay, can insert those factors. This one can go in as is. The next one, I'm going to go ahead and put that in. I'm going to reduce this to 1/1, but I want to put in my labels to keep everything in the right place. And then finally, the last one's going to have to flip because I have moles on the top. When I multiply and divide, so I multiply 4897 by 64, divide that by 97.5. Sorry, that was my phone. Okay, so I was taking 4897 times 64 divided by 97.5, and I get 3,214 grams of SO2. This is my theoretical. So what I can do here is I can take this, plug this in back here. I get 3214. So I have the actual amount divided by 3214 times or equals 0.867. And when I solve that, I end up with 3,108 grams expected. So sometimes we find the percent yield, sometimes we can use the percent yield to find what we should get. But this is then the answer I was looking for. So our takeaways here, percent yield, are what you actually get in a reaction divided by what you thought you would get, the theoretical amount. You multiply that by 100, and we can use that a couple of different ways. We can use it, we can find the percent yield, or we can use the percent yield to work backwards and find what we expect. Okay, that wraps up the chapter. Thanks for watching. See you in the next one.